All right, so what we're going to look at in this video is types of reactions. So we're going to identify the type of reaction based off of the chemical equation, which I have written here. And when we're identifying types of reactions, remember we have decomposition, we have synthesis, we have single replacement, double replacement, as well as combustion. So those are the 5 main types you're going to need to identify in this chapter. We are then going to balance by putting coefficients in these spaces. And then we'll move on to some more difficult problems where we're predicting products. So let's start with what type of reaction is this? What is our reaction type? So looking at it, we have one reactant, KClO3, breaking apart into 2 products. So this would be a classic decomposition reaction. All right, decomp down here. So the properties of decomposition are when you have one reactant breaking apart or decomposing into 2 products. Okay, so let's look now at balancing. So when we're balancing a chemical reaction, it's important that you have the same amount of atoms on both sides of the equation. Because atoms cannot be created or destroyed. We need to make sure we're keeping track of it all, that it's the same amount. So what I'm doing now to balance, I'm making a list of every element present. I'm going to do this on both sides because I'm going to count my atoms, go back and forth until it's balanced. So for potassium on the reactant side, how many atoms do I have? Just 1. Notice there's no coefficient after the K, so it's just 1 atom of potassium. For chlorine, also 1. Oxygen, 3. Coefficient, or the subscript, sorry, after oxygen is sub 3. So that means there are 3 oxygen atoms. Let's move over to the product side. We have 1 potassium, 1 chlorine, and 2 oxygens, because now the coefficient, the subscript on this side is a 2 after the oxygen, so that means there are 2 atoms of oxygen. So now we compare and see, do they balance? Well, our potassiums, same amount on both sides. That's balanced. Our chlorines, same amount on both sides. That's also balanced. Oxygens, not. Okay, so this is not a balanced reaction, and I'm going to have to start adding coefficients to make those oxygens become balanced. Okay, so I have 3 oxygens on the reactant side. I have 2 on the product side. All right. So that means I need more oxygens on the product side. So if I put a 2 here, now how many oxygen atoms do I have? Remember, to figure that out, you're taking your coefficient, so I'm going to write that up here, coefficient times subscript. So I'm going to take the coefficient of 2 and multiply it by the subscript of 2, and that's going to give me now 4. Okay. Well, now, comparing the oxygens, I have too many oxygens on the product side. Right, I have 4 on the product side, 3 on the reactant side. So I need more on the reactant side. So I'm going to put a 2 here now. Because right now there's essentially a 1 there. So I'm just going to up it 1 number at a time and go from there. So how did that change my oxygens? I do coefficient times subscript, so 2 times 3 is 6, so I have 6 oxygens. But notice this 2 applies not just to the oxygens, it's going to apply to the whole compound. So it's going to change my potassiums, and it's also going to change my chlorines. So how many potassiums do I have? Do the coefficient 2 times subscript, which in this case is a 1, so we have 2 potassiums. Going with chlorine, we also have 2 chlorines. So now everything's out of whack. But looking at potassium, chlorine, and oxygen, I have more of them on the reactant side than the product side. So just pick one to balance and go from there. So I'm just going to look comparing the potassiums to each other. I have 2 potassiums on the reactant side. How am I going to get 2 on the product side? What number can I put here to make me have 2 potassiums? Number 2. So if I put a 2 there, that's going to change my potassiums to 2. It's also going to change my chlorines to 2, which is okay because I needed 2 chlorines anyway. All right, so we have potassiums and chlorines balanced once again, and now let's look at those pesky oxygens. So I have more oxygens on the reactant side. I need 6 oxygens on the product side for it to balance. So let me remove this number here, this coefficient. Now what coefficient, what number can I put there that will make me have 6 oxygens? A 3, because coefficient 3 times subscript 2, 3 times 2 is 6. Now it's balanced. So 2, 2, 3 is a balanced chemical equation for that decomposition reaction. All right. Now let's look at another reaction type. So we have NH2 plus H2 gives ammonia NH3. Put spaces in front because the coefficients are what we're going to change when we balance. Before we balance, let's look at what type of reaction this is. Okay, so we have 2 reactants coming together to form one product. So whenever we have 2 reactants combining to form one product, that is a synthesis or combination reaction. Now let's balance. So to balance, we're going to make a list of all elements present. We have nitrogen and hydrogen. Over here, we have nitrogen and hydrogen. So let's do a quick atom count. Nitrogen, just 1. Hydrogen, notice it's in 2 places, so add them together. Okay, so 2 hydrogens here, 2 hydrogens there, for a total of 4. On the product side, I have 1 nitrogen and 3 hydrogens. So nitrogens are balanced, hydrogens are not. I have 4 hydrogens on reactant, 3 on the product side, so I need more here, so let me just put a 2. So that is going to change my hydrogens to 6 because coefficient times subscripts, 2 times 3 gives me 6 hydrogens. But it's also going to change my nitrogens. I now have 2 nitrogens. Okay. Well, let's go back over here to the reactant side. So let's just focus on the nitrogens. I have 2 nitrogens on my product side. What number can I put in here, in this space, to have 2 nitrogens on the reactant side? It's number 2. Now that 2 is going to affect the hydrogens as well. So 2 times 2 is 4. Okay, but you also have to remember you have 2 more over there. So that's a total of 6. Now it's balanced. 2, and this is an empty space. Empty space, you assume the coefficient's a 1, and then 2. So that gives the balanced chemical reaction of that synthesis reaction. Let's try another one. All right, so we're going to work on predicting products. While we do this, we're also going to balance the equations and identify the type of reaction, just because those are things we need to know how to do as well. So let's start out with identifying what type of reaction it is. Now, you might think this would be difficult because we only have the reactants, but it actually tells us enough in order to indicate the type. So if I have aluminum, metal by itself, reacting with a compound. So out of synthesis, decomp, single replacement, and double replacement, and combustion, what type of reaction is this? So it's going to be single displacement. All right. So single displacement because element by itself reacting with a compound. Okay, so now we need to predict the products. In order to predict the products, I want you to write each element and what its charge is. Okay, so to do that, the periodic table is going to help you. So we have aluminum right here, group 13. So aluminum is going to have a 3+ charge when it's in a compound. It's neutral right now, but when it's in an ionic compound, it'll have a 3+ charge. Hydrogen's in this first column here. So hydrogen is going to be a +1. Chlorine is a halogen. Remember, what are the halogens? They are -1. All right, so the reason we write the charges is because that will help us figure out who's switching partners, or who's switching, who's replacing whom, and then help us predict the compounds afterwards. Okay, so going over to the product side. Now I have a cation, aluminum, and hydrogen's also a cation. So these are the two that are going to switch spots. So aluminum with that 3+ charge is now going to be with chlorine, who has a -1 charge. And hydrogen now is going to be by itself. Remember, when an element's by itself, it no longer has a charge. Okay, and hydrogen specifically, remember, it's unstable by itself, so it's one of those nonmetals that forms a diatomic. Okay, so H2 is going to be one of our products. Now, aluminum and chlorine are going to be together, but what is the chemical formula going to be? Because when you switch partners, write it this way, new partners means new subscripts. All right, so how do we figure out what the new subscripts are going to be? We learned this in chapter 3, crisscross method. This charge on aluminum is going to become the subscript on chlorine. This charge on chlorine is going to become the subscript on aluminum. So that means I need 1 aluminum and 3 chlorine, so ACl3. That is my new product. So now that I predicted my products, I can balance the equation. Balancing equations, we write a list of every element present and how many atoms of each. We use the subscripts to tell us that. So on the reactant side, I have 1 of each element there. On the product side, 1 aluminum, 3 chlorines. And for hydrogen, subscript of 2, so I have 2. All right. So to balance, aluminums are balanced. Hydrogens, not balanced. Chlorines, also not balanced. Okay, so I'm going to start with the chlorines. 3 on the product side. I need 3 on the reactant side, so if I put a 3 here, that's going to change my chlorines to 3. It's also going to change my hydrogens to 3. Now notice over here on the product side, I'm never going to get an odd number of hydrogens. It's just not going to happen because I have a 2 here. So if I put a 2, I'm going to have 4 hydrogens. If I put a 3 there, I'm going to have 6 hydrogens. If I put a 4 there, I'm going to have 8. See where I'm going? So there's always going to be an even number of hydrogens. Right? So I'm never going to be able to get 3. So what I'm going to do instead, if I put a 3 here, that's going to give me 6 hydrogens. Right? So now let me go back over to the reactant side. So I have 6 hydrogens on the product side. I have 3 hydrogens on the reactant side. I need 6. So what number am I going to put here to get 6? A 6. That's also going to change my chlorines. Now I have 6 chlorines. Right? Moving back over to the product side. I need 6 chlorines over here. So what number, what coefficient can I put there to give me 6 chlorines? Put a 2 there. 2 times 3 is 6. But it also changed my aluminums. How many aluminums do I have now? 2. So hydrogen's good, chlorine's good, aluminums are not. I need more aluminums. I need 2 aluminums over on the reactant side. So now it is balanced. 2, 6, 2, 3. All right, let's try predicting products again. So let's look at a new reaction. Oops, writing in purple, that's okay. Plus F2. My spaces gives me, oh, almost wrote the products. This is what we're trying to predict though. So I have sodium chloride reacting with fluorine. So remember, fluorine is actually an element by itself. There's 2 atoms of fluorine, but that's just because fluorine's more stable when it forms a diatomic, just like hydrogen in the last problem. Okay, so what we're going to do is we're going to write the elements and the charges that they form, the ions they form, when in a ionic compound. So sodium, alkali metal, +1. Chlorine, halogen, so -1. And then fluorine here is also going to be a -1 because it's a halogen as well. All right, so this time it's the anions that are changing places. So my product over here, fluorine, is going to take the place of chlorine. So then I have sodium with fluorine, because we need positives and negatives together. And then chlorine now is going to be by itself. And when chlorine's by itself, just like fluorine, it's going to form a diatomic. So one of my products, Cl2. Now what is my other product going to be? Remember our crisscross method? 1 and 1. Or you might have noticed charges cancel, so it's already balanced. So NaF. Remember, new partners means new subscripts. Notice over here I had a subscript of 2 after fluorine. Over here I don't have a subscript of 2 after fluorine. You need to do the charges to figure out what the subscripts are going to be. And this was a single displacement reaction, just like the last one. Let's balance this guy. Sodium, chlorine, fluorine. Sodium, chlorine, fluorine. Okay, for sodium, we have 1. Chlorine, 1. Fluorine, 2. Sodium 1, chlorine 2, fluorine 1. So I'm just looking at the subscripts. Sodiums are good, chlorines aren't. 2 on the product, I need 2 on the reactant side, so I'm going to put a 2 there. That changes my sodiums to 2. It changes my chlorines to 2. So let's go back over here and get 2 sodiums on the product side. I put a 2 there, that changes my sodiums to 2. And it changes my fluorines to 2. Now it's balanced. All right, let's try one more. What's this? So we have aluminum bromide with potassium sulfate. Let's predict the products. So in order to predict the products, we need to know the type of reaction. Notice we have a compound reacting with a compound. So out of all our choices, synthesis, decomp, single, and double displacement, the only one that has 2 compounds reacting together, 2 ionic compounds reacting together, is double replacement. So what that means is these guys are going to be switching places. Okay, So to figure out who's switching places, we approach it the same way we did a single displacement, where we write each element and its most probable charge. Remember, SO4 is a polyatomic, so you would find that -2 charge on the polyatomic table. Now when these guys switch places, it's the cations that are going to switch. So that means potassium on the product side is going to be with bromine. Aluminum, instead of being with bromine now, is going to be with the sulfate. New partners means new subscripts. So make sure to do your crisscross method if necessary. So this one I don't even need to do anything. Charges already cancel. So my product's just going to be KBr. For this guy, aluminum, 3+ is going to become the subscript on SO4. The 2 is going to become the subscript on aluminum. So what that means is I need 2 aluminums and 3 SO4s. Since it's a polyatomic, I'm putting parentheses and then the 3 on the outside of the parentheses. All right, so there's my products. Let's balance. When you're balancing and you have a polyatomic, something that's really going to help you is to keep the polyatomic together. So what I mean by that is I'm going to write aluminum, bromine, potassium, and I'm going to write SO4 instead of splitting up the sulfur and the oxygen, because that's just going to make my life easier. Over here I'm going to do the same thing, and I'm just keeping it in the same order because it's easier for me to keep track of when I compare. So aluminum, 1. Bromine, 3. Potassium, 2. Now the sulfates, there's just one of them. There's one SO4. So think of parentheses here and just a 1. So that's the number I'm looking at for how many. Potassiums, 1. Bromine, 1. Aluminum, 2. SO4s now is the number outside of the parentheses, 3. Are my aluminums balanced? No, so I'm going to start there. 2 on the product side, I need 2 on the reactant side, so I'm going to put a 2 here. That brings me to 2. But it changes my bromines now to 6, because I do coefficient times subscript. All right, let's move and do my potassiums. Actually, let's do my bromines, because I just changed that one to a really big number. So bromines, I have 6 bromines on the reactant side. I need 6 on the product side, so I'm going to put 6 there. That changes my potassiums to 6 as well. All right, so aluminums, bromines, good. Now let's move on to the potassiums. 6 on the product side. I need 6 on the reactant side. So what number can I put here to give me 6? There's a coefficient of 2 there, so what times 2 equals 6? 3. So it gives me 6 potassiums, and now 3 sulfates, which I needed 3, so it balanced itself out. All right, well, I hope that helped with predicting products. This will be useful in doing the next lab, Lab 9.